stoichiometry. Stoichiometry is a method that utilizes a balanced equation to determine the quantity of a reaction component. Only one quantity is necessary to determine any other quantity in the reaction. Key right here, and I will drive this point home in a few minutes. Okay, on the other board, what we're going to do is we're going to write down a list of steps that we follow as we are working problems utilizing stoichiometry. Number one, balance the equation for the reaction that you're looking at. Number two, convert known, or the given known, or the given mass to moles Number three, you're going to use a balanced equation. So use the balanced equation to set up a mole ratio. What is this mole ratio that I speak of? The mole ratio is the heart of the stoichiometry problem. It's not a very good heart. Let's try that again. There, that's good. All right. Number four. Use the appropriate mole ratio. I'm going to abbreviate mole. calculate number of moles of unknown, and then finally number 5, convert moles to grams if required by the problem. Okay, I could go on and on about this, like talking about it beforehand, but I think the best way for us to go about this is to just go ahead and do a couple of problems. And as we're going through the problems, I will try to explain to you what we're doing and why it is we're doing what we're doing. But these steps, I think, will make it helpful for you when you are staring at a problem and you don't have any idea where to begin. Balance the equation. Okay. Okay, now here in the beginning, I will always give you the equation. Reactants and products. But as we continue on this year, you won't always get the products. I'm going to expect you to know how to predict the products and write the formulas for the products. But not for right now. For right now, we're just focusing on this method to determine quantities of reaction components. Okay. So our question is going to look like this. What mass of oxygen will react with 96.1 grams of propane. So we want to know if we've got 96.1 grams of propane and we react it with oxygen, how much oxygen, what mass of oxygen will react with this much propane? Alright, so we will use the quantity of propane to calculate the quantity of oxygen utilized. So the first thing that we need is an equation to represent this reaction. So our equation is going to be C3H8, okay, that's the propane, and it's a gas, and it's going to react with oxygen. It's also a gas. This is a hydrocarbon, a chute. Combining with oxygen, reacting with oxygen. It always gives the same two products. It does not matter what the identity of this hydrocarbon is. It will always give the same two products. What are they? Carbon dioxide and water. So carbon dioxide and water. Okay, just like the methane we looked at yesterday. Same, methane. It's a different formula, CH4 plus oxygen, but it gave the same two products, carbon dioxide and water. All right, so here's our given chemical reaction, and the first thing we need to do with that thing is to balance it. So pause, you balance that equation. All right, let's see if you did it right. So I've got 3 carbons. I need 3 carbons. I've got 8 hydrogens. I need 8 hydrogens. I've got 2 oxygens. And now I have 3 times 2 is 6. Plus 4 is 10. So that means I need here. Okay, and let's go back through this thing and make sure we're good. 3 carbons, 3 carbons. 8 hydrogens, 8 hydrogens. 10 oxygens. 3 times 2 is 6, plus 4 is 10. Okay, good, we're balanced. Okay, we can look at this in 2 ways. We can look at this as 1 molecule of propane reacts with 5 molecules of oxygen to yield 3 molecules of carbon dioxide and 4 molecules of water. But we're never going to be able to hold that amount, that quantity in our hand and measure it. And so we speak in terms of moles. 1 mole of propane reacts with 5 moles of oxygen to yield 3 moles of carbon dioxide and 4 moles of water. All right, so there's our balanced equation. Now, we want to know if we've got 96.1 grams of this, how much of this will react with it. That is the purpose. So oxygen, mass of oxygen, grams of oxygen is our unknown. Grams of propane are what we are given. So the first step is going to be, we're going to start with 96.1 grams of C3H8. And I'm going to put that over 1. All right, the next thing I need to do is I need to convert grams of propane to moles of propane, because remember, these coefficients are not relating mass to one another. They are relating moles, numbers of things with each other. So this grams, yeah, it's a useful measurement for us to quantify something, but in terms of ratios here, it doesn't help us at all. We need to go to numbers of pieces of things. So we need to convert grams of propane to moles, and we know that conversion factor. That conversion factor is molar mass. Okay, so molar mass of propane is 44.1 grams of propane per mole of propane. Essential to write these formulas. Essential. Because they're going to guide you in what you have to do next. Great. I've got moles of propane. I know this part is set up correctly because my grams of propane will cancel. Okay, so now I've solved for moles of propane, so I know how many moles of propane this represents. I'm not looking for moles of propane. What am I looking for? Well, eventually I'm looking for mass of oxygen. So I have got to convert this moles of propane to moles of oxygen. And to do that, I am going to use something we call the mole ratio. And the mole ratio relates any 2 quantities to each other in a balanced equation. So, we're going to do some mole magic right now. I'm going to put, because I want to cancel it, moles of propane in my denominator. And what am I looking for? I'm looking for oxygen. Oxygen is unknown. And so I'm going to put moles of O2 in my numerator. That's my unknown. That's what I'm looking for. This is my known or my given. Always, people. Unknown is in the numerator of your mole ratio. Given or known is in your denominator. Okay. So, mole to mole, how do they react? What is the ratio of their reaction? Well, for every 1, I need 5. For every 1, I need 5. So they are in a 5 to 1 mole ratio. The heart here of the stoichiometry problem, right? We can use the mole ratios of any two to find an unknown quantity. All right. So we convert we cancel moles and moles. Where does that 1 come from? The coefficient of the balanced equation. 5. Coefficient of the balanced equation. All right, now in my problem, sometimes you guys, you're asked for moles. You don't have to solve for mass. And if you're solving for moles of your unknown, then you'd be done at this point. As well, sometimes you guys, your given is given in moles, and you don't even have to do this conversion step. You just start with however many moles you're given in the problem. Okay, I'm making this the most complicated problem we can have up to this point. All right, so I am not looking for moles of oxygen, I am looking for mass of oxygen. So how am I going to change this moles of oxygen to mass of oxygen? I'm going to use the molar mass for O2. And O2 is 32.00 grams of O2 per mole of O2. My moles of O2 cancel, and I'm left with grams of oxygen in the numerator. Okay, you go ahead right now and you do this math and see what you get. 96.1 divided by 44.1 times 5 times 32.00. No need to divide by 1. And, of course, I've always left this up to you, so I better calculate this. I'm sure we have a right answer. So you're sure you have a right answer. Okay, so we go 96.1 divided by 44.1 times 5 times 32 equals that just doesn't look like a right answer to me. I'm going to try it one more time. 96.1 divided by 44.1 times 5 times 32 equals, I am getting just a oh, no, I see what it is, okay. So I'm getting 348.662. And so how many sig figs can we have? You can have 3 sig figs. So I'm going to make this thing 349 grams. 349 grams of O2. Okay, what does this number mean? This is the mass of oxygen that will react completely with 96.1 grams of propane. All right, let's do one more. And this one more that we're going to do, you guys, we're going to do it from product to reactant. So it does not matter at all what side of the equation you're given and your unknown is on. No matter what quantity you're given in this reaction. And don't let the fantastical, fluffy words of a problem confuse you with it. No matter what quantity you're given, if you're given a quantity of a product and you're asked for the quantity of the other product, you can do it. If you're given the quantity of a product and you're asked for the quantity of a reactant that formed it, you can do it. Okay, so you just take what you're given, you start with what you're given, and you moved through to what your unknown is. It doesn't matter where they fall on any side of the arrow. Okay, so let's do another one. I'm going to leave my balanced equation. I'm just going to change my question. So let's say, how many grams of propane were consumed to form, let's say 23.5 grams of water. Okay, I'm just going to cut through all of this. Consumed, I don't want to know it. What I want to know is what is my given and what am I looking for. You just cut through all the vocabulary. What is my given and what am I looking for? I am given 23.5 grams of water. I am looking for grams of propane. That's it. That's all you need to know, guys. The rest of it consumed. And there's going to be all kinds of flowery words, all kinds of things put in a problem that will confuse you. And you need to distill it down to what am I given and what am I looking for. Okay, and then you just let the units guide you. So let's do this thing. I start with, let's go with green. I start with what? 23.5 grams of water. That's my given in this problem. 23.5 grams of water. Okay, so if I get 23.5 grams of product, this product, I can find out, well, how much propane did I use to produce that amount of water? Okay. Or if I want to make this much water, how much propane do I have to use? Right? There's all different ways we can look at this thing. Okay, so I can't do anything with grams, right? The first thing I've got to do is I need to convert my known to moles. unless it's given to me, but I didn't do that for you. Okay, so 23.5 grams, and water is 18.02 grams per mole. 18.02 grams of water per mole of water. So very, very important that we're right in the water, because that lets us know that we have set up our mole ratio correctly. We can cancel out the correct units, and we know that our mole ratio is right. Okay, so my grams of water cancel. Excellent. My unknown is not water. My unknown is propane. How many grams of propane? So, I'm going to do some mole magic here. I'm going to set up my mole ratio. So, I'm going from moles of water. Okay, see why it's so important. Okay, my moles of water will cancel. So moles of water, and what am I looking for? Moles of C3H8. But that's not a real mole ratio. I need some numbers here. So what is their relationship in this reaction? For every 1, I make 4. Or we could think of it, to make 4, I need 1. All right, so my ratio is then 4 to 1. All right, and my moles of water will cancel. And last but not least, then I need to change my unknown from moles to grams. So I'm going to use the molar mass of propane to do that. Fortunately, I have that written on my notes right here. That's going to be 44.1 grams. 44.1 grams of propane per mole of propane. Do I have this set up correctly? Do all of my units cancel? That's what I need to look for. Okay, so my moles of propane cancel my moles of propane. I have grams in my numerator. That is my only unit that does not cancel, and that's what I'm looking for. That's my unknown. So I am set up correctly. And so now I just need to do a little math. 23.5 divided by 18.02 divided by 4 times 44.1. And so the answer to this problem, 23.5 divided by 18.02 divided by 4 times 44.1 equals, how many sig figs? I've got 3. Oh, I don't want to lose my, lost my answer in the lights. I think it was 14.4. That's annoying. 23.5 divided by 18.02 divided by 4 times 44 point, I wrote the wrong number. Let's solve it again. 5 divided by 18.02 divided by 4 times 44.1 equals 14.4. 14.4 grams of propane. Okay, so if I've used 23, if I've made 23.5 grams of water, how much propane must have been utilized? 14.4 grams of propane. Or if I want to make 23.5 grams of water, how much propane should I use? 14.4 grams. Get stoiked.